My name is Bo, and I am a final element engineer in USC Geocomposite Center, and I'm working on multiple projects related to composite structures for aerospace applications. This project is to optimize the aerospace structures design parameters, and we used Nastran and Patran to simulate the model for the aerospace parts, which is called hair stiffener. And this hair stiffener is widely used in aerospace wing sections and the fuselage. So the aircraft industry in recent years has increased reliance on carbon fiber composites material. So composites also offer the potential for reducing part count and increase the fatigue resistance and reduce the maintenance frequency. Through the simulation using Nastran and Patran for the aerospace parts, we want to develop a design space for different parts for aerospace industry, so that they have a database that generated by our project. They can look into it when they are doing some future design based on the work we have done, and use the method that we invented to implement these methods into their product design. In a modern airplane, for example, Boeing 787, more than 50% of its weight is composites. So composites plays a very large role in modern airplane. And these hair stiffeners are the main stiffened parts that makes your wing section more stiffened. The reason that we use the Nastran and Patran is because it has very good feature cooperating with different CAD software. So we have different models from different software that we can implement into these Patran and Nastran for the calculation. The second reason we chose Nastran and Patran is because it's automatic parametric modeling feature. So once we programmed the feature that we want, the computer can just run by itself 24 hours and then generate thousands of different shapes and different configuration for the aerospace parts. And we're trying to find out the best one among these different parts. So it's called an optimization design. So we can send all these models to Nastran for the calculation. So when we get the feedback, we will know which shape is better.
Projects can be initiated in a couple of different ways. In some cases, an agency, for instance, the Navy, issues a solicitation. In the case of Bo's project, this was, as I mentioned, an SBIR project. These are typically led by the business entity and supported by the university entity. This one was a company called Next Gen Aeronautics. They're basically a small business research company that specializes in small aircraft, drones, unmanned vehicles, and things like that, and in the research to support those types of vehicles. Being able to say that we are proficient and competent in the use of the MSC software was extremely important to the success of the proposal and to the project. In the context of a simulation, we're able to perform hundreds of iterations that are just prohibitively expensive to do in experiments. That enables us to screen and optimize much more quickly and cheaply than real experiments.
The simulation used in Nastran and Patran actually reduce the iterations of realistic testings and provide a very good guidance for our future design of the hair stiffeners and aerospace parts. Using the simulation allows us to save tons of money, millions, because we don't have to spend that much of human resource and material resource and also time resource on all the real tests, but instead we can do the virtual simulation in computers to get the results as a guidance for the future design.